You know what really stings? It is not making a mistake in the shop. Mistakes happen. What stings is when you add up how much money you have thrown at a problem that somebody else solved 1,000 years ago. I spent years buying sawn lumber from the yard, hauling it home, stacking it in my shop, and watching it twist, cup, and split before I even got a project finished. And the hardware. Do not get me started on the hardware. Stainless steel screws, bronze fasteners, marine grade this and that. Hundreds of dollars in metal that was supposed to hold everything together, and half of it was corroded or loose within a couple of seasons. Then, about 5 years ago, I stumbled into the world of Viking boat building. Not the Hollywood version with horned helmets and battle axes. The real thing. The actual craft. And what I saw stopped me cold. These people were building vessels that crossed the North Atlantic, hulls that flexed through ocean swells, planks that held together for decades, and they did it with hand tools, no sawmill, and almost no metal. Every single problem I had been throwing money at, they had already figured out. Today, I am going to walk you through 7 secrets from the Norse shipwrights that completely changed how I think about wood, structure, and building things that last. And stick around to the end, because I have a bonus tip on how to read a log before you ever split it. Something I picked up that I have never seen in a single modern woodworking book. Let us get into it. Viking boat building is not some dusty historical curiosity. It is one of the most efficient, resourceful, and downright brilliant woodworking systems ever developed. And the beautiful part is, almost everything these shipwrights figured out applies directly to work you and I do in our shops today. Once you see the thinking behind it, you will never look at a stack of lumber the same way again. So let me start with who these people actually were and why their methods deserve your attention. When most people hear the word Viking, they picture raiders and longships. But behind every one of those famous vessels was a tradition of shipwrights that stretched back centuries. Men who learned their craft from their fathers and grandfathers in a chain of knowledge that was ancient, even by the time the Viking Age began around the late 700s. We know about their methods, not from guesswork, but from hard evidence. Ships like the Gokstad vessel, buried around 890 and excavated in 1880, survived over 1,000 years underground, with their construction details perfectly preserved. The Oseberg ship, dating to around 820, still had its original tool marks visible on the planks, and the Skulderlev ships, a group of 5 vessels sunk deliberately in a Danish fjord around 1070 and recovered in the 1960s, gave archaeologists an incredibly detailed picture of how these boats were actually built. What struck me when I started studying this was how practical everything was. These were not artists trying to make something pretty. They were working tradesmen, solving real problems with limited resources. They had no sawmills. They had no power tools. Iron was expensive and scarce, so they used as little of it as possible. And they were building for the most demanding environment on Earth, the open North Atlantic, where a structural failure did not mean a warranty claim. It meant you were dead. The guiding principle behind all of it, and this is what changed my thinking the most, is that they worked with the wood instead of against it. Every decision they made, from how they selected a tree to how they fastened a plank, was built around respecting what the wood wanted to do naturally. And once I understood that one idea, every single technique made perfect sense. Let me show you what I mean, starting with the most fundamental secret of all. The first secret is to reeve your planks instead of sawing them. This is the single biggest difference between Viking woodworking and what most of us do today, and it is the one that would have saved me more money than anything else on this list. When you take a log to a modern sawmill, the blade cuts straight through the wood without any regard for where the grain fibers actually run. You get nice rectangular boards shear, but those boards have severed grain lines running right to the surface. That is why sawn lumber warps. That is why it absorbs water unevenly. That is why it splits at the ends. You have cut across the very fibers that give wood its strength. Viking shipwrights did not saw their planks. They split them. The technique is called riving, and it works by driving wedges, or a tool called a froe, along the natural grain of the wood so the log separates right down the fiber lines. What you end up with is a plank where every single grain fiber runs continuously from one end to the other, completely unbroken. The difference in performance is dramatic. A riven plank is stronger in bending because those continuous fibers act like millions of tiny ropes running the full length of the board. It is more flexible because the fibers can slide past each other, slightly under load without snapping. And it is far more resistant to water penetration because the surface grain has not been sliced open the way it is in sawn lumber. I tried this for the first time with a straight-grained red oak log about 4 years ago, using a froe, and a wooden mallet. The log was about 14 inches in diameter, and I split it into planks roughly 3/4 of an inch thick. Those planks were more uniform, more stable, and stronger than anything I had ever brought home from the lumberyard. And the wood was free. I cut that log from a tree that came down in a storm. That is the first secret. Stop sawing. Start splitting. Your wood will be stronger, more stable, and it will cost you almost nothing. The second secret is choosing the right wood for the right job. Vikings did not walk into a lumberyard and grab whatever was on sale. They matched each species to a specific purpose based on its natural properties, and they were ruthlessly practical about it. For the keel and the hull planking, they used oak almost exclusively. European oak, which is very similar to the white oak we have here in the States. Oak is dense, rot-resistant, and it rives beautifully along its medullary rays, those flecks you see in quarter-sawn oak. That ray structure actually helps the wood split cleanly and gives the riven surface a natural water resistance because the rays act like tiny dams running across the grain. For masts and spars, they switch to pine or spruce. These are lighter, more flexible, and they grow tall and straight. You do not want a heavy, rigid mast on a sailing vessel. You want something with a little give that will bend in a gust instead of snapping. The Norse shipwrights understood this perfectly. But here is the part that really impressed me. For frames, ribs, and knees, the structural pieces that need to follow a curve, they did not cut curves out of straight lumber the way most of us would. They went into the forest and found trees with natural curves, a root flare where a trunk meets the ground, a branch junction that formed a natural right angle, a tree that had grown on a hillside and developed a sweep in its trunk. These pieces, called crooks, have grain that follows the curve continuously. That means the curved piece is just as strong as a straight one because no fibers have been severed. Compare that to what happens when you bandsaw a curve out of a straight board. You are cutting across the grain at every point along that curve, and the result is a piece that is dramatically weaker and prone to breaking right at the point of maximum curvature. The Vikings never had that problem because they let the forest grow their curved parts for them. The takeaway here is simple. Think about what each piece in your project actually needs to do, and choose your species and your grain orientation accordingly. Do not just grab whatever is convenient. Quick thing before we move on. Everything I am sharing today comes from years of studying how the old shipwrights built, and I have gathered the best of what I have found into a book called Secrets of the Shipyard. 16 chapters, 25 hand-drawn illustrations, 150 pages of real craftsmanship knowledge. Scan the QR code on screen or hit the link in the description if you want to take these lessons off YouTube and into your shop. Now, back to what I learned. The third secret is one that turned my understanding of construction completely upside down. Vikings built their boats shell first. That means the outer planking went on before there was any internal framework at all. In modern boat building, and in most construction generally, you start with a skeleton. You build a frame, a rib cage of sorts, and then you attach the skin to it. It makes intuitive sense. Skeleton first, skin second. But the Norse shipwrights did it backwards, and there is a brilliant reason why. They started at the keel and worked upward, adding one overlapping plank at a time in what is called clinker or lapstrake construction. Each new plank overlapped the one below it by about an inch to an inch and a half, and they fastened the overlap with iron rivets. As they built upward, the hull took shape organically. The planks themselves, because they were riven and had continuous grain, had a natural springiness and curvature that defined the hull form. Only after the shell was complete did they fit the internal frames. And here is the key. Those frames were not pre-built to a blueprint. They were individually shaped to match the hull that had already been formed. Each rib was custom fitted to the inside of the shell, following whatever shape the planking had naturally taken. The result is a hull that is astonishingly light for its strength. Because the planking is doing most of the structural work, the frames can be much thinner and lighter than they would need to be in a frame-first design. A Viking longship that could carry 30 warriors and their gear across the open ocean might have hull planking only an inch thick. The whole vessel could flex as a unit, almost like a living thing. When I first understood this, I realized I had been overbuilding everything in my shop for years. I was constructing massive internal frameworks and then attaching thin panels to them, when in many cases, the panels themselves could have been doing more of the structural work if I had just used better material and smarter joinery. The fourth secret is about fastening. And it is the one that hit my wallet the hardest when I realized what I had been doing wrong. Vikings fastened their planks with iron rivets and roves, and for many structural connections they used wooden pegs called tree nails, which most people pronounce as trunnels. A rivet and rove is simple. You drive a square-shanked iron nail through both overlapping planks from the outside, slip a small iron washer, called a rove, over the point on the inside, and then peen the nail tip over the rove with a hammer. What you get is a fastener that clamps the two planks tightly together and will not pull out because the peened head locks it permanently. But tree nails are where the real genius shows. A tree nail is just a round wooden peg, usually oak or sometimes a very hard fruitwood, driven into a slightly undersized hole. In a boat, when those tree nails get wet, they swell, and as they swell, they lock tighter into the hole. The joint actually gets stronger in the exact conditions where a metal fastener would start to corrode and loosen. I spent years fighting rusted screws and corroded bolts in outdoor projects. Deck screws that snapped off flush when I tried to remove them. Lag bolts with so much rust jacked up around the head that they split the wood. Meanwhile, the Vikings solved this problem a millennium ago with a wooden peg that costs nothing and gets tighter over time. Every time I pull a rusted screw out of a failed joint now, I think about that. The fifth secret is natural waterproofing. Between every overlapping plank seam, Viking shipwrights laid a thin rope of wool or animal hair that had been soaked in pine tar. This is called caulking, though it works differently from the caulking most people think of today. The tarred wool was pressed into the seam before the planks were riveted together, so it was trapped in the overlap. As the wood swelled from water contact, it compressed the wool tighter, creating a seal that actually improved over time. Then they coated the entire exterior hull with pine tar, real pine tar, rendered from pine stumps and roots. This is not polyurethane. It is not epoxy. It is a natural, breathable coating that penetrates into the wood fibers, resists water, discourages rot and marine borers, and can be reapplied every season with nothing more than a brush and a warm pot of tar. What I love about this system is its honesty. Modern sealants try to create a permanent barrier, and when they fail, which they always do eventually, the trapped moisture causes rot that you cannot see until it is too late. Pine tar does not pretend to be permanent. You renew it regularly, and every time you do, you are inspecting the wood underneath and maintaining the protection. It is a system designed for maintenance, not for neglect, and it works beautifully. The sixth secret changed how I buy wood entirely. Viking shipwrights did not just grab any tree. They read the timber while it was still standing. They looked at the bark pattern, the spiral of the grain visible on the trunk, the shape of the crown, and the way the branches were distributed. A tree with a straight trunk, evenly spaced branches, and tight bark with vertical fissures was likely to rive cleanly into good planking. A tree with a spiral grain or heavy limbing on one side would be rejected or reserved for a different purpose. They also felled exclusively in winter when the sap was down. A winter-felled tree has lower moisture content in the sapwood, which means it seasons faster and more evenly. The starches and sugars in the sap are at their lowest, which makes the wood less attractive to insects and fungi during the drying process. And speaking of drying, they air seasoned their timber slowly, not kiln dried in a week. Air dried over months or even years, depending on the thickness. This slow, patient drying allows the internal stresses in the wood to equalize gradually. The result is timber that stays flat and true once it is finally worked, because all the movement happened during seasoning, not after you built something with it. I used to buy kiln-dried lumber and wonder why it moved on me after a few months in the shop. Now, I understand that wood was dried too fast. The outside was dry, while the inside was still holding moisture, and as it eventually equalized, it twisted and cupped. Since I started buying green wood, splitting it myself, and air drying it properly, I have had almost zero problems with wood movement in my finished projects. Almost zero. The seventh and final secret is the one that ties everything else together. Vikings designed for flex, not rigidity. A Viking longship does not fight the ocean. It rides with it. The thin riven planks, the lashed frames, the overlapping construction, all of it allows the hull to twist and flex as waves pass underneath. You can actually see this in reconstructed Viking ships under sail. The hull visibly writhes as it moves through the water. It looks alarming if you are used to rigid fiberglass boats, but it is exactly what keeps the ship alive. A rigid hull in heavy seas takes the full impact of every wave as a shock load. A flexible hull absorbs that energy by bending, distributes the force along its entire length, and springs back. This principle applies far beyond boats. Every piece of outdoor furniture you build, every garden gate, every deck, every structure exposed to seasonal moisture and temperature swings is going to move. The question is whether you design for that movement or try to prevent it. The Vikings teach us that flexibility is not weakness. Flexibility is survival. Let me share some patterns I have noticed over the years, things I used to do myself that the Viking tradition handles completely differently. The first pattern is defaulting to sawn lumber for everything. It is convenient. You drive to the yard, pick your boards, and go home. But sawn lumber has severed grain, and that compromises strength, stability, and moisture resistance right from the start. Riven wood solves all three problems at once. The second pattern is reaching for screws and metal fasteners as the automatic choice. I did this for decades, but metal corrodes, it creates stress points in the wood, and it makes repair difficult. Tree nails and rivets are often stronger, cheaper, and more durable in the long run. The third pattern is building rigid structures and then being surprised when they crack or joints open up. We over-engineer for stiffness when we should be designing for controlled flexibility, especially in anything that will live outdoors. The fourth pattern is ignoring grain direction when selecting wood for curved or structural parts. Cutting curves from straight stock is wasteful and weak. Finding or growing natural curves gives you a part with continuous grain that is dramatically stronger. The fifth pattern is rushing the seasoning process or trusting someone else's kiln schedule. Properly air-dried wood is more stable, more predictable, and more pleasant to work than lumber that was forced dry in a kiln. The good news is, once you see these patterns for what they are, you can start shifting your approach one project at a time. You do not have to build a longship. You just have to start thinking the way the shipwrights thought. Now for that bonus tip I promised at the beginning. This is something I learned from studying how Norse shipwrights evaluated timber before felling, and I use it every single time I look at a log now. Before you split a log, walk around it and look at the bark. On most oak and many other hardwoods, the bark develops vertical fissures, long cracks running up and down the trunk. If those fissures run straight and parallel, the grain inside is likely straight and the log will rive cleanly. If the fissures spiral around the trunk even slightly, the grain inside is spiraling too, and that log will fight you when you try to split it. Next, look at the branch stubs or knot bumps. Every knot represents a place where the grain dives inward toward the center of the tree. A log with knots clustered on one side will rive unevenly because the grain is disturbed in that area. You want a clear section of trunk with at least 4 feet between any visible knots. Finally, look at the crown of the standing tree before you fell it. A symmetrical crown with evenly distributed branches usually means the tree grew straight and the grain inside is uniform. A lopsided crown often means the tree was leaning or competing for light, and the grain will have reaction wood, compressed fibers on one side that behave unpredictably. I have been using these 3 checks for about 3 years now, and my riving success rate went from about 1 in 3 to nearly every log splitting clean. It takes 30 seconds of observation and saves hours of frustration. That is the kind of quiet, practical wisdom that the old shipwrights carried in their heads, and it works just as well today as it did 1,000 years ago. If these Viking shipwright methods are something you want to keep studying, I have put everything I have learned into a book called Secrets of the Shipyard. 16 chapters covering techniques that have been refined over centuries, the kind of knowledge that does not show up in most modern woodworking books. Scan the QR code on screen or check the first link in the description. I think you will get a lot out of it. These 7 secrets are not just interesting history. They are the foundation that everything else on this channel builds on. Working with the grain instead of against it, choosing the right material for the right job, designing for movement instead of fighting it. These are principles that apply to every single project you will ever build, whether it is a boat, a bench, or a bookcase. The Vikings did not have power tools or fancy hardware. They had sharp eyes, sharp axes, and a deep respect for what wood can do when you let it do what it wants. I think that is something worth learning from. Thanks for watching, and I will see you in the next one.